Welcome to the Deep Dive, brought to you by EasyMasterAI.com, your shortcut to being truly well-informed. Today we're diving headfirst into a topic that's rapidly reshaping the tech world, how artificial intelligence is transforming software testing. We're going to unpack the most important insights from Mark Winteringham's really compelling book, Software Testing with Generative AI, which is published by Manning Publications. Our mission today is to get a handle on how these large language models, LLMs, have sort of democratized AI access in software development, and crucially, how you can leverage them to profoundly enhance and speed up your software testing efforts. Have you ever wondered if AI could make your testing faster or maybe smarter, or even help you find things you wouldn't normally find? Well, this deep dive explores exactly that.
Yeah, it's a question a lot of us have been thinking about, isn't it? Especially with how incredibly fast AI has moved. I mean, not that long ago, using AI meant a huge investment. You were talking developing, training, deploying custom models, maybe hiring a whole team of data scientists. It was expensive and really only available to a few. But as Winteringham's book lays out so well, that whole landscape has just dramatically shifted. The explosion of LLMs, think ChatGPT, Gemini, Llama, it's truly democratized AI. It puts these powerful tools right into the hands of developers and testers, through things like code assistants and intelligent chatbots.
That's a massive shift, isn't it? It's quite remarkable. The author even mentions using an AI assistant for his own book's preface. It really makes you think, okay, if these tools are so easy to get hold of now, how does my role change? Like, what new skills do I actually need to harness this AI, rather than just feeling kind of overwhelmed by it? And the book apparently stems from those exact questions, offering a really critical look at how we can integrate LLMs to enhance the testing we're already doing.
Precisely. And a core insight the book really hammers home is that testing, well, at its heart, it's a collaborative thing. LLMs aren't here to just replace human testers. The idea is they act as powerful collaborators, enhancing our work, speeding things up. The book's goal is really practical, give you the skills to spot where and how to use these models effectively. It introduces this concept called the area of effect model, which basically says that the real value of any tool, whether it's AI or Hammer, comes from the relationship between the user and the tool. It's all about blending our unique human abilities, our intuition, our critical thinking with the AI's power to generate and analyze stuff.
Okay, and that actually leads us straight into something pretty crucial and maybe a bit surprising. The book really emphasizes the absolute need for skepticism. It stresses that LLMs are not some kind of, single oracle of truth. You can't just blindly accept what they spit out. The book explains that LLMs are fundamentally predictive. They look at these massive data sets and predict the most likely next word or phrase. But this predictive thing has a hidden catch. They can hallucinate. They can confidently serve up completely false or just nonsensical information. Winteringham gives this great example of ChatGPT recommending a book that just doesn't exist. It sounds totally authoritative, but it's completely made up.
That's such a critical point, and it has really big implications. If we just blindly accept the output, we risk slowing ourselves down, or worse, actually hurting the quality of the product. You are still the one leading the problem solving. If your prompts are vague or shallow, well, the responses are going to be shallow too, making the AI's suggestions pretty much useless. And beyond hallucinations, there are these significant concerns around data provenance and privacy. We often don't really know the full picture of what data these LLMs were trained on. There have been very public accusations, companies like X, formerly Twitter, and Reddit accusing OpenAI of basically stealing data wholesale. And there are class action lawsuits about copyright infringement because models were trained on copyrighted stuff without permission. The book even points out how training on weird, nonsensical data, like from Reddit's counting thread, can lead to just strange, unreliable outputs. It's a stark reminder if an LLM is trained on garbage, it's going to produce garbage. So you have to be incredibly careful about what sensitive or company data you send to third-party LLMs because of their privacy policies.
Right, so understanding how these LLMs actually work, the nuts and bolts, is super important then. The book digs into that in Chapter 2, and it's actually surprisingly easy to grasp. Think of it like your phone keyboard's auto-suggest feature, but just on an absolutely massive scale. An LLM works in a similar way, using probability based on huge data sets to predict what the next word should be. That's the basic idea behind things like generative pre-trained transformers, or GPT.
That's a perfect analogy, really. And once you get that basic mechanism, you can start to really harness their power through what the book calls prompt engineering. This is presented as an absolutely essential skill for anyone who's interacting with these LLMs. And the first core principle of good prompt engineering is simple. Write clear and specific instructions.
Yeah, and a really effective tactic for that, which the book highlights, is using delimiters. just using something simple like triple hashes or quotes around your data. This helps the LM clearly see the difference between your instructions and the data it needs to process. So for instance, if you want it to generate SQL insert statements for, say, hotel rooms with specific randomized data, the delimiters make sure it understands the structure and the rules you're setting. It makes the prompts clearer and way easier to change later on.
Exactly. Another smart tactic under that same clear instructions idea is asking for structured output. If you explicitly say the format you want, like convert this JSON booking data into YAML format, the LLM can quickly reformat that data just how you need it. And crucially, to cut down on those hallucinations we were talking about, you need to actively check for assumptions. This means giving instructions for the LLM to basically bail out, to say, I can't do that if it can't fulfill a request properly, rather than just guessing. Remember that example about extracting email addresses where the LLM just made up .com emails because there weren't any in the data? An assumption check like that can stop those kinds of errors.
That's incredibly smart, like setting up guardrails for the AI.
Yeah.
And few-shot prompting is another powerful technique mentioned. That's where you just give the LM a couple examples of the input and the output you want. It's like showing it, okay, this is the kind of thing I'm looking for, guiding its response in real time.
Right. The second big principle is to give the model time to think. Now, this might sound a bit strange for a machine, but what it really means is breaking down complex tasks. One way is to specify the steps. Tell the LLM, okay, first, identify the functional risks, then convert those into test charters, and finally, format those charters exactly like this. This turns a big, vague problem into a series of smaller, more manageable steps for the AI.
And one of my favorite tactics for giving the model time to think, which the book mentions, is instructing it to actually work out its own solution first before it gives you the final answer. There's a great example with Java unit tests. If you ask it to evaluate its own suggested solution, maybe to make sure the results are deterministic, before it outputs the code, you find it minimizes errors. Like ensuring it uses something like Mockito for a more reliable test. It's like asking it to double-check its work.
It's all about guiding that predictive process more effectively, making it more reliable. The book also touches briefly on how different LLMs stack up. OpenAI's GPT 3.5 Turbo and GPT 4o, Meta's Llama models, and community hubs like Hugging Face. They differ in things like parameter count, the data they were trained on, and just the subtle quality of their responses. So experimenting a bit to find the right tool for your specific job is definitely a good idea.
But a quick word of caution here about multi-prompting, or like long conversations. While tools like ChatGPT are great for back and forth, relying on a really long chain of prompts actually increases the risk of hallucination. The model might try too hard to overfit its responses based on the whole conversation history. It can lead to delays and just less valuable output. Remember that garbage in, garbage out idea? It applies just as much to lots of shallow prompts as it does to one single bad one. Clarity and being concise are really key, no matter how many prompts you end up using. Okay, so with that kind of foundational understanding of LLMs and prompt engineering under our belts, how does this all actually apply to the practical day-to-day world of software testing? The book makes a really compelling case that the true value of testing isn't just about confirmation, like ticking boxes. It's really about information gathering and sharing knowledge. It introduces this great imagination implementation model. It shows how different testing activities, from user experience testing, exploratory testing, performance testing, even writing automated test scripts, they all focus on fundamentally different kinds of risks.
Yeah, that model is really crucial because it helps us see exactly where LLMs can fit into the whole testing lifecycle. For developers, the book points out how LLMs can effectively act as pair partners, almost like a rubber duck, a way to verbalize problems and find solutions. They can sort of simulate roles, helping you brainstorm ideas or troubleshoot issues, especially when maybe human colleagues aren't available, or you just need a fresh, objective perspective.
That's a powerful idea. And this extends to analyzing ideas really early in development, where people call shift-left testing. LLMs can generate a whole series of probing questions based on user stories and also quality characteristics like accuracy, security, accessibility, things like that. This helps uncover assumptions and misunderstandings long before any code gets written. Think about generating questions like, okay, how are guests actually guided to create accounts when they first land on the site? Questions like that can spark much deeper thinking and maybe expose potential problems much earlier than just confirming basic requirements.
And this ability isn't just for abstract ideas. LLMs can analyze actual code snippets too. They can review code to identify risks, things like potential SQL ejection points, maybe inadequate authorization checks, performance bottlenecks. They do this by focusing on those same quality characteristics we mentioned. But of course, the human element is still vital here. You still need to be able to tell the difference between a concrete, actionable suggestion and one that's just too vague or maybe irrelevant to your context.
Oh, right. And building quality in from the start, especially with things like test-driven development or TDD, that also gets a boost. While LLMs like GitHub Copilot probably won't completely replace a developer's deep analytical skills or their understanding of the system, they can rapidly generate unit checks. This speeds up that crucial TDD cycle of red-green refactor. It's a real augmentation, making you faster, not replacing your brain.
And documentation, too. They can significantly improve documentation. Think about generating code comments for a really complex timesheet class, maybe, or extracting concise, relevant release notes directly from the code changes. That saves a ton of time and helps make sure the documentation actually stays relevant and in sync with the code base, which is often a struggle.
Okay, so we've seen how LLMs can really give developers a boost, from early analysis right through to TDD and docs. But the real leverage often goes way beyond just the code itself. What about the crucial art of test planning? That fundamental activity, how can AI reshape that? The book really reinforces that risk is at the absolute core of effective testing, and this seems like an area where LLMs can really help out.
Yes, definitely. By using more abstract representations, like maybe data flow diagrams or UML models as input for your prompts, you can feed more specific context to the LLMs. This leads to much better, much more targeted risk suggestions. For example, if you break down a complex booking API into its individual parts and feed that structure to the LLM, it can suggest a really precise set of risks tied to each specific component. It shows, again, how being precise with your input gives you much better results.
It's also about using what the book calls mental models or heuristics. These are like thinking tools. Think of powerful mnemonics like SFDIPOT, that stands for structure, function, data, interfaces, platform, operations, time. It's like having a systematic checklist to uncover potential blind spots. By deliberately shifting your focus to the product structure, then its function, the data it uses, its interfaces, the platform it runs on, its operations, and even how it behaves over time, you'll spark completely new test ideas. It's a really powerful framework, and LLMs can actually help expand on those systematic probes, giving you even more angles to explore.
And if you do need specific, detailed test cases, LLMs can generate those too, based on the risks you've defined and the user context you provide. Whether that's detailed steps for testing user speed, or maybe scenarios for concurrent users hitting a booking list, they augment your thinking and coverage. They don't dictate it.
Then there's the often underestimated yet incredibly complex area of test data creation. I mean, managing realistic, useful, and properly anonymized data can be such a huge time sink. This feels like an area where LLMs offer really amazing possibilities for just rapidly generating and transforming this data.
Oh, absolutely. It's a huge help. From generating simple JSON or XML data based on some clear rules you give it, right up to handling complex data that needs to follow industry standards like OpenAPI or XSD specifications. LLMs can generate data with really intricate relationships between different parts, saving immense amounts of time, especially when you're dealing with large data sets, like maybe XML documents that have over 1,000 different elements. This is a real game changer for setting up your tests efficiently.
And this can be plugged directly into your automation frameworks, right? The book shows how you can programmatically use, say, the OpenAI API through something like LangChain 4j. You can use it to generate dynamic test data right when you need it for your automated UI checks, like filling out a contact form with fresh AI-generated data for every single test run. But, and this is a crucial reminder, the book makes always stick to your internal company policies and data privacy laws when you're using any real or intellectual property data with these external LLMs. Data security has to be paramount.
Right. Shifting gears a bit to UI automation, LLMs like ChatGPT and Copilot can be fantastic for rapidly creating boilerplate code. Things like page objects, which are fundamental for making UI automation robust and maintainable. This saves a huge amount of time compared to coding every single element locator for pages like a contact form page or a login page by hand.
But, and this is really important, it's vital to recognize the limitations here. LLMs fundamentally lack deep product context. They might suggest generic data that, doesn't actually pass your specific application's validation rules, or they might completely miss the need for crucial weights in your automation scripts, which leads to those flaky tests that fail randomly. Human oversight and critical adjustments are still absolutely essential to make the generated code functional and, more importantly, reliable.
And to take it a step further, the book illustrates how interacting directly with APIs, maybe sending HTTP POST requests to create messages instead of clicking through the UI, can make your UI automation much more robust and way faster. By bypassing the UI elements when they aren't strictly necessary for the test you're running, you reduce your reliance on those sometimes fragile UI interactions, and that can speed up your test cycles dramatically.
Okay, finally, let's touch on assisting exploratory testing. This is really where human creativity and intuition shine, but the book shows LLMs can still powerfully augment our human heuristics. When your own ideas for expanding on identified risks or maybe fleshing out test charters start to run dry, an LLM can provide a fantastic creative boost. For example, helping you expand on a vague thought like the navigation controls don't work properly into a set of concrete, testable scenarios.
They can also help with test data generation right during an exploratory session. Imagine quickly spinning up SQL scripts or maybe Node.js scripts to create massive test data sets like, say, 1,000 bookings on the fly, just for the specific exploratory scenario you're investigating right then. Or they can help you apply those powerful thinking mnemonics like PALO, that's portrait, audio, objects, landscape, overlaid to a specific feature, maybe a booking report calendar. Applying that framework can trigger entirely new test ideas specifically for things like responsive UI design across different devices and orientations.
And here's a real time saver: transforming your raw notes into structured reports. LLMs can take your messy, raw exploratory testing notes and convert them into organized formats, like testing stories, or maybe using the Cornell Notes method. This makes sharing knowledge with your team and reporting your findings so much more efficient and accessible. Okay, now let's talk about taking this whole thing even further, customizing LLMs for much deeper integration into your specific workflows and environments. The book dedicates a good portion to this, starting with the really fascinating concept of AI agents.
Right. An AI agent is a pretty significant step beyond just simple prompting back and forth. The book defines an agent as having a few key characteristics. It's perceptive, meaning it can interact with the outside world, maybe pull information from a website, or interact with a system like a database to get results. It's also autonomous. It can decide how to solve a problem rather than just following a strict pre-programmed path. And finally, it's adaptive. It can learn from its actions and react to new information it gathers to better achieve its goals. This is where AI starts to feel like it's really acting more independently.
The book even walks you through building a kind of dummy agent using a framework like LangChain 4J. It shows how you can link an LLM up with specific tools, maybe tools to, say, create room in a test database, create booking, or display database contents. What's really clever is how these agents can intelligently pass data between the tools. Like, you could take a roomid that comes out of the Create Room tool and automatically feed that into the Create Booking tool. It becomes a chain of automated actions driven by the LLM.
Yeah, this opens up some incredible potential for really advanced automation or even highly sophisticated test idea generation agents that could autonomously interact with your system to find issues. However, it definitely comes with significant challenges. Their deterministic nature can sometimes make them feel like a black box, making it hard to observe what they're doing or debug them when things go wrong. There are also real concerns around setting up robust guardrails to control their behavior, ensuring security, and, frankly, the significant cost involved in building, deploying, and maintaining these more complex systems.
Okay, another powerful customization technique discussed is RGE, which stands for Retrieval Augmented Generation. This directly tackles a core problem with standard LLMs. Their limited context windows or token limits.
Yeah.
You simply can't feed an LLM your entire code base or all your project documentation or your whole database schema and expect it to just absorb it all perfectly. Too much data can actually dilute the accuracy, and you'll hit those token limits pretty quickly.
RGE is a really elegant solution to this. Here's how it works. When you send a query to the LLM, a RGE system first intelligently searches a predefined corpus of data. This could be your internal documentation, your code repositories, maybe database entries, whatever you've set up. It searches this corpus specifically for information that's relevant to your query. Then it takes that highly relevant targeted data and combines it with your original query. This combined package forms a much more informed, much more precise prompt that gets sent to the actual LLM.
The benefits here seem huge. It should dramatically improve accuracy because the LM is working with context that's highly specific and relevant to the question being asked. It cleverly gets around those context window errors, gives you much better control over which data sources the AI uses, and lets you use all sorts of internal data types. The book even mentions building a RAG setup specifically to find relevant user stories from a backlog and then using those to generate targeted testing risks. It highlights how specialized tools, like vector databases, Pinecone is mentioned as an example, are pretty essential for storing and efficiently retrieving these documents for the RAG process.
And finally, the book covers fine-tuning. Now, while RLAG is all about enhancing the prompt by adding external context just before calling the LLM, fine-tuning is about enhancing the model itself. It's like taking a pre-existing foundational model, a base model like GPT, and putting it through additional training. This further training biases its internal parameters, its knowledge, towards a desired tone, a specific style, or maybe domain-specific context relevant to your company or industry. ChatGPT itself is a good example. It's essentially a fine-tuned version of a foundational GPT model, specifically tailored for better conversational interactions.
And the process for fine-tuning sounds pretty involved. It involves several quite rigorous steps, setting really clear goals for what you want the fine-tuned model to be good at. Meticulous data preparation, thinking about the size, the quality, maybe using synthetic data and understanding its pros and cons. Then there's pre-processing the data, the actual tuning loop, where the model's parameters are tweaked over many epochs, basically. Training rounds, and finally, really rigorous testing of the resulting model. Tools like the axolotl framework are mentioned as ways to help make this complex process a bit more accessible.
Yeah, and it's really important to clearly contrast array and fine-tuning because they solve different problems. RG provides targeted, relevant context at query time and enhances the prompt. Fine-tuning, on the other hand, is about fundamentally teaching the model new behaviors or embedding domain-specific knowledge through that additional training, actually changing its underlying capabilities. Fine-tuning generally has a much steeper learning curve, it involves higher costs both for specialized hardware and the talent needed, and it has a slower turnaround time to get a usable model. However, it offers much more granular control over the model's behavior. It's especially valuable for enterprise-specific applications where maybe data privacy is paramount, or you need the model to truly speak your company's specific language and understand its unique context.
And testing these fine-tuned models is absolutely critical, isn't it? The book mentions this can be done through inference, which might involve things like automated sentiment analysis, comparing the model's output to what you expected, or, importantly, through human validation, where people actually review the model's responses to new prompts to make sure it's behaving as intended. It sounds like a journey of continuous improvement, constantly refining the model based on how it performs. So as we kind of wrap up this deep dive into Mark Winteringham's software testing with generative AI, it becomes incredibly clear, doesn't it? Generative AI isn't really about replacing human testers or developers, not at all. It's much more about augmenting our abilities, almost giving us superpowers we didn't have before. It's about finding that sweet spot, that right balance between our uniquely human skills, critical thinking, creativity, intuition, and the AI's incredible power for generation, transformation, and finding patterns or suggestions.
That's the real takeaway for you, the listener. In this new era of software development and testing, the ultimate skill for professionals probably won't just be how to use AI tools. It'll be knowing when to step in and lead with your human judgment, and when to intelligently lean on the AI to accelerate things and enhance the quality of your work. It's really about understanding the strengths of both human and machine, and then orchestrating them together, hopefully in perfect harmony.
Absolutely. And look, this deep dive has really just scratched the surface of how AI can supercharge your testing and development work. To learn more about AI, explore some powerful tools out there, and even discover how you might be able to leverage AI for various applications, including making money with AI, definitely visit easymasterai.com. That's easymasterai.com. We really hope you've enjoyed this deep dive, and we look forward to exploring more fascinating topics with you next time.